Hey, welcome. This is our lesson for 5-2. Today we were graphing an inverse function. So, first part here, when you undo an equation, the original input becomes your output. And we talked about that yesterday in the previous lesson, how about when we put in our inputs into our original functions, they become the outputs. And then when we put them in the inverse function, we put the outputs in and we get the inputs out. So there's a little diagram down here to kind of re-explain that. Right, so our original equation, we have our x and our y, right? So we have x and y as an ordered pair. And when we got to the inverse, we undid it there, we would take it and we would put our y value in, and then the x value would be our output there. Okay, so our x's and y's are those coordinates we're switching places. If you want to look at it in terms of numbers, that might make a little bit more sense instead of all these letters. You know, if 3, 4 was in our original function, if we looked at our inverse function there, the point 4, 3 should be a point on that graph. All right, so today we're going to graph some of these. We're going to start out here, number 1. We have y is equal to 0.5x plus 3. Now this is just a line, and usually we see the line in slope-intercept form. We don't really deal with decimals a lot, so I'm going to go ahead and just change the form there and make it y equals 1/2 x plus 3. Okay, now the first thing here is I would like to come up with the inverse function. And if you think back to the way we did it yesterday, okay, we took it there and we listed out the steps. So this is our original. And we looked at the steps, or the order of operations of what we would be doing to the input. So our x was our input, so the first thing we would have done there was multiply by half. So you could put 1/2 if you wanted to write it there. And after we did that, we would add 3. That means then our inverse function, when we do that one, remember we have to undo each of these steps. So the first thing we would do here is undo the add 3. So we would subtract 3 first. And then we would, instead of multiply by half, we would divide by half. Or you could say, 1/2. Now dividing by half is the same thing as multiplying by 2. And we'll look at that here as we build it. So as we build this one here, I'm just going to use y. I'm using the little -1 here just to denote it's the inverse. But we've got x as our input. We said we're going to subtract 3 first, and then we're going to divide it by half. Now dividing by half, we usually don't want to have fractions and fractions, so we know that's the same thing as multiplying by 2. So I have here instead, you could write it in this form, 2 times the quantity of x minus 3. And just to help us with graphing purposes, why don't we just take that here and let's distribute our 2 through. So we now have 2x minus 6. Okay, so one of our functions is 1/2 x plus 3. The other one is 2x minus 6. And let's see here, if we graph these inverse functions, if there's anything here that we may recognize as some special characteristics. So the first one, let's go ahead here, let's graph the y equals 1/2 x plus 3. I'm going to do that one in red. So our y-intercept here is at positive 3. We're going to rise 1 and run 2. So it's got a positive slope. And we're going to graph that line. Let's do our best here to graph it as straight as we can. It's going to be close enough. It's hard to graph straight on here. I don't really have a straight edge that I can use, so bear with me, please. Let's write down some of the points here that we see from our x and y. Okay, so this first function, the inputs and outputs we would have here. I'm going to list just a few of them. This one looks like it's 1, 2, 3, 4, 5, -6, 0. And maybe I'll try to mark these in a different color so you can see which ones I'm talking about. Let's see here. We've got one right here. It looks like it's at -4, 1. Then we've got one at -2, 2. Then we've got one at, looks like 0, 3. And let's see, we got room for maybe one more on there. Let's do this one here. This looks like it's the 0.12, and then 1, 2, 3, 4. So we've got 2, 4. Okay, so those are some points that we see on our original function. Now let's go ahead and let's graph our inverse function. Our y-intercept is at -6, and our slope is +2. So we're going to rise 2 and run 1. Now I'm going to graph this one. There, and you'll see we get our line. Okay, now when we take this one here, let's write down some of its ordered pairs. Let's start down here on the y-axis of this big point at the bottom here. That would be the point 0, -6. And I'm listing these on the bottom table over here. Then I've got the point 1, -4. We've got the point 2, -2. We've got the point 3, 0. And we've got the point, let's just say here one more. We've got the point, what is that, 4, 2. And what I really want you to look at here is the ordered pairs that we come up with on both of these. We talked about how the x's and the y's were switching, right? And this should be evident here when you look at the tables of the two functions. Okay, there's some other characteristics we'll talk about between these two graphs, but let's move on to the next one, and then we'll come back and talk about this one a little bit more in a moment. So the next problem that we graphed in class was this one. Y is equal to 3 times the quantity of x plus 2 squared minus 6. So with this one here, if we want to create the inverse function, okay, let's list out our steps here. This is our original. So it looks like if we knew what x was, the first thing we do is add 2. Then we would square it. Then we would multiply by 3. And then we would subtract 6. For our inverse, let's take it here and let's rewrite them. I'm going to do this in red underneath here. So we're going to add 6 first. Remember, we're going to undo these from the end back to the beginning. And then we're going to divide by 3. Then we're going to take the square root. And then we're going to subtract 2. If we want to build that here, let's build it underneath. We've got, we're starting with x, and we're going to add 6 to it. We're going to divide that by 3. We're going to take the square root, and then we're going to subtract 2. So as we take this here, let's go ahead and let's graph our original first. And then we'll come back and talk a little bit more about our inverse function here. So to graph our parabola here, we know that our locator point is going to be at -2, -6. If you want to pause the video and go ahead and graph it, go for it. I wouldn't want to listen to me any more than I had to either. Stretch factor's 3. I just hope you're doing it right. So we went over 1, up 3, we go over 2. Normally we go up 4, but now we're going to go up 3 times that amount, so we're going to go up 12. All right, now we have that one graphed here. If you're not real great at graphing functions that look like this, okay? And this one would require having a positive or negative in it here. We'll talk about that more later this week. We haven't graphed anything that looks like this inside of the square root. So what we can do then, another technique for graphing, is let's just take the points that we had from our first one. We're going to flip them and then create a table for our inverse function and then graph those. So our original function here, the one in blue, so the first point I'm going to do here, I'm going to highlight it, is this one. That point right now is the point negative 1, 2, 3, 4, 6. The x-intercept there, okay, it's somewhere between negative 3 and negative 4. We don't know exactly what it is, but just make sure you take note of that. You don't have to list the exact coordinate if you don't want to. But I'm going to go over to the next point here, which would be, it looks like negative 3, negative 3. Then we're going to hit the next one there, which would be our negative 2, negative 6. The next one after that looks like it's negative 1, negative 3. And then this one here looks like our y-intercept there would be at 0, 6. Okay, so this was our original function. That means that our inverse, if we are doing this correctly and understanding, we should be able to come up with its points by just simply flipping the ordered pairs from our original. So instead of just having negative 4, 6, this would be 6, negative 4. Now negative 3 is easy because it already reflects itself there. Instead of negative 2, negative 6, this one should have negative 6, negative 2. Negative 3, negative 1, and then 6, 0. So let's go ahead and plot those on our graph. Let's go over to the right 6, and then down 4. We've got negative 3, negative 3. So they share that point. Then we've got the point negative 6, negative 2. Then negative 3, negative 1. And then we've got the point 6, 0. So this parabola here is laying on its side. What are we noticing here? Well, and this is the reason we had to have the positive or negative in our function here when we wrote out that equation, because our square root function would have been just the top of our parabola here that we just graphed, right? So we also need the negative version of that square root function in order to complete the parabola and actually have our inverse. Next thing we want to talk about here is symmetry. Inverse equations are always reflected over the line y equals x. Remember, that's a line where our slope is 1, and so our y-intercept is 0. I'm going to graph that line in here. Let's pick a color that might stand out. Let's do pink. We should be going up right through the origin. Boom, right through there, right? Our line has a slope of 1 there. Notice you can see the symmetry across there, right? It kind of splits it in half there. It's a reflection across there. Okay, so that's why we have points like negative 3, negative 3, because all of these points on this graph, this is the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, all that there. Those ones will always be on that line of symmetry. So you'll see those points like negative 3 on there. Those are points that they will end up sharing. If we look back at our previous graph here from the last problem, notice this one will also have a line of symmetry that runs along that line y equals x. This is an important characteristic here, and we're going to talk about it more as we get into graphing more of these tomorrow. Okay, so this isn't the only day of graphing these, but this is something that we pointed out in class, and we discussed it a little bit more in class. We also went over today on how you can use your TI Nspire to help you with checking your inverse graphs. Okay, And there's 4 steps here. You're going to take it, you'll graph your original equation. Then you're going to press menu. You're going to choose option number 1, which is actions, and then option number 5, which is text. You're going to click on the screen there, and then you're going to enter in this equation into the text box. Press enter, and then you'll drag it down to the x-axis. I'll show you how to do that in class. I showed everybody here today. You were absent, so hopefully you'll have some time to come in and get some extra help.